All right, this is lesson 4.7 in algebra. Lesson 4.7, special functions. Okay. Anyway, one of the special functions they have is called a step function. I am not going to explain that to you right now. I'm just not. It looks like this. It looks like steps. Oops. I honestly, right now, do not care that you know how to even get that, but that's called a step function, okay? This is not vital, and so I'm not going to go over it. The one that I do want you to go over, though, is we're going to talk about an absolute value function. An absolute value function looks like this. First of all, have we talked about parent functions before yet? Okay, I will show you a parent function. A parent function is a function that is kind of the standard by which we judge. Let me make this a little smaller. Okay. A parent function. You actually do know one. You just don't realize it yet. Function. A parent function looks like this. Y equals X. Oh boy. Okay. First of all, is that written in slope-intercept form? Absolutely. Y equals X is written in slope-intercept form. The parent function to slope-intercept form would be this. And what that does is it looks like this. Okay, here's our graph. What would it look like? You know how to do this. What would it look like? Where would it cross the Y? 0. It crosses the origin. And what's the slope? 1, which means up 1 over 1. So then the parent function, this thing's graph, would look like this. Do you agree? That's the parent function. What the parent function's function is, what its job is you can now adjust other functions to the parent function based on what the new function looks like. For example, if I had one that was y equals 2x, what does that mean that's going to happen in relationship to the parent function? What's going to be the only difference? If the slope is going to be steeper, right? Compared to the parent function, the slope is going to be steeper. So our new function here would be a 2, right? But it's still going to the origin. But I compared this to the parent function, and I know that simply because of that 2, my new function is going to be, my new slope is, my new graph, my new line is just steeper than the parent function. If I had another one, and it was y equals x plus 4, what's the difference between this and the parent function? What is the difference between this and the parent function? Everything is exactly the same except it's shifted up 4, right? So then all of a sudden now everything's identical except it is up 4. Does that make sense? Comparing it to the parent function, you can do it, you look at the parent function and you can adjust your function to the parent function. Okay, let me go back here. There's the parent function again. What if I gave you y equals 1/2 x minus 3? Comparing it to the parent function, which is y equals x, what's going to be different? You know this. What's going to be different about ours? It's going to be, it's a negative slope, so it's going to be going from left to right down. Sorry, it's not true, it's not a negative slope. What's it going to be? It's going to be, use the word steeper and shallower. Come on. It's going to be a shallower slope, and it's going to be down 3. So it's going to look something like this. More shallow and down 3. Do you understand what I'm saying? This is the parent function to slope-intercept form. Okay? The parent function for an absolute value function is f of x. Where else could I put there instead of f of x? Y. But f of x equals the absolute value of x. That is the parent function for that is the absolute value's parent function. Okay? What this looks like is this. I will show you what it looks like. On the coordinate plane, it would look like this. It's going to cross at the origin, and it's going to be Oops, that's not right. That's not right either. Nope. Come on. I can't get it. Nope. I have to draw it myself. Bye. It makes a V. And its epicenter, its center, is at the origin. Okay? How would I know if that's true? What could I do with this to find out if that's true? Make a table, right? Turn this into, what is f of x also equal to? Y. So let's do that. Let's go y equals the absolute value of x, which is make a table if x, we'll do -2, 0, and 2. If x was -2, what's y equal to? 2. If x was 0, what's y equal to? If x is 2, what's y equal to? 2. That means that here is my graph. It would look like this, 0, 0. Right there's 1 point, there's another point, there's another point. Do you see them? You see what I'm talking about? Do you see it or no? Okay. So there's the parent function. Here is how we're going to deal with this. I'll show you what happens when you start changing things up. Okay? Here's what happens. 1, if you have your parent function, f of x equals, and you put a 2 out in front of the x, you know what happens? It acts a whole lot like slope-intercept form. What do you think happens if I put a 2 out there? What do you think happens? Hold on, let me help you out here. What if it was this, y equals x? What is that a parent function to? A slope-intercept form, right? What if I put a 2 out in front of that x? What would happen compared to the parent function? What would happen? The slope would get steeper. What do you think happens here? The slope of this gets steeper. What would happen is this function would look like this. The crosses here and here. Does that make sense? If this was a 5, what would happen? It would be even steeper. Does that make sense? What if there was what if I put a negative out here? What do you think would happen? What would happen, do you think, Bubba? Wouldn't shallow. If I put a negative out there, let's talk about this. Let's go back to this again. If I have y equals x, what's that look like? So it is slope-intercept form. What does that thing look like? It looks like this, right? Agreed? Do we not just do that? Okay. What if, so there's my normal guy. What if I made this a negative? What would happen to it? It goes this way, right? So then let's compare again. I've put a negative out here. This guy here is this. If there's a negative out there, what's going to happen to it? It's going to be upside down. Does that make sense? It's going to be upside down. Now, here's the other thing. What if I have this? F of x equals absolute value of x, and then I put a +2 out there in the end, outside of the absolute value part, but there's a +2. Try to take some guesses here, take some chances here. Since a lot of things are similar, what do you think is going to happen here to this, Barbie?
Up 2.
Everything gets shifted up 2. That would simply be this. Does that make sense? It acts a lot like the y-intercept. It gets shifted up 2. Make sense? Okay. What if I had this and it wasn't a plus, it was a -4? What would happen? It's down 4. Same thing compared to the parent function, except it's shifted down 4. Make sense? Okay. What if I did this, though? Here's the weird, tricky one. What if I have a +3 inside of the absolute value? Here's the tricky part. Pay attention. This is new. I know you haven't done this before, so you want to pay attention. What if there's a plus 3 inside the absolute value? I'll tell you what happens. This is where it gets shifted left and right. It's the opposite of what it looks like. So a plus 3 there means that I'm going to go to the left 3. Everything stays the same except it gets shifted to the left 3. If this was a minus 5 in there, then everything gets shifted to the right 5. It'd be over here. Make sense? Well, so here's the deal, Dizzy. Yeah, I could, if we were to show you if I was to make a table on each one of these, you'd go, oh, I see it. I'm just not making the table. I'm just telling you what happens. Does that make sense? The explanation is that it just does. I'm just not taking the time to write a table each time. But it just does. Okay? So, let's see how many of you can do this. Here we go. This will be for a air high five. Anybody who can get it. Okay? Air high five. They're kind of rare. Graph that for me. I'm going to change one thing. I'm going to make that a plus 3 at the end. That's it. Okay, so here we go. Just watch. You should be done right now. If you've got this, just watch. You're watching now. Everybody's eyes up here. 3 different things you're looking for when you're doing an absolute value function is you've got the thing that comes before that acts like the, what does this act like? What's this act like? And what does this do? Left and right, but it does the opposite, right? So it's that simple. So look, first thing we're going to do is go left and right. It's an x plus 2 in there. What does that mean I'm going to do? Go to the left 2. That's this way. So we're right here along here. Does that make sense? We're here. But what does this plus 3 mean? We're up 3. So it actually means we're right here. Does that make sense? Left 2, up 3, and then that 2, this 2 here means it's a 2 slope. How many of you got that? 4 of you. Wow. Great job. No, not a great job. Do another one. Do another. Oh, air high five. That's true. Air high five. Air high five. Air high five. Okay, doesn't matter. Okay, here we go. Try this one. F of x equals here we go. Remember the parent function is right here, right? Well, yeah, right there. That's the parent function. Okay, we're not worried about the parent function right now, but we are comparing it to the parent function, right? The parent function is the thing we're comparing it to. Compared to the parent function, what's the first thing you should recognize and go, what do I do with that thing? What do I see? Okay, but there's something you should notice here that a lot of you drop all the time, and you can't do that. What do you see that should make you go, wait a second, something's not right? Yeah, there's a negative here. When you have an absolute value function and there's a negative outside of there, listen, if there was a negative inside, what would that do? Nothing. If there was a negative inside, it wouldn't do anything. Why would it do nothing? Because it's absolute value. Does that make sense? But if there's a negative outside, then we now have to deal with this, and that makes this whole thing upside down, right? It's an upside down V. It's not a regular V, it's an upside down V. That's what the negative means. But okay, that we can deal with that in a second. Let's get this thing right. This thing's going to, it says plus 4. That means I'm going to go to the left 4, and the plus 1 means I'm going up 1. So left 4, up 1, we're right here. This is what that's called. This is going to be the vertex. Okay, this is going to be either the maximum or the minimum. We'll talk about that in a second. This thing's upside down. What's the slope, by the way? It's a 1, right? It's a negative 1, which means it's upside down, and it's going to be perfectly, down 1 over 1. That's what it should look like. Now let's talk about this. Domain and range. Do you remember the words domain and range from before? We did that like first chapter, I think like day 2. The domain and range. Here we go. Domain and the range. What those words mean is this. The domain is all of the numbers that x could possibly be. Domain is the x. All the numbers that x could possibly be. Now I need you to look at this. You're up here with me. You're up here looking. Here we go. Here's my little laser. According to this, what could x be and have y still be a number? Have y be a part of our answer? See how it's going down this way forever? It's going down this way forever, right? What could x be? Could x be 1,000,000? If x was 1,000,000, which is way over there, right? If x was 1,000,000, would there be an answer for y? Would this thing eventually go down there and meet it down here somewhere and have y be equal to something? Yeah. What if x was negative 1,000,000? Way over here, right? Way over here. Would there be an answer for y down here with this thing going that way forever? Would there be something down there? Yeah. So x could be anything, right? The answer to this would be all real numbers. The domain for this is anything. X could be anything, and there's going to be a y for it. Does that make sense? Range, so the domain for this is ARN, all real numbers. The range is all the numbers that y can be, right? Now look at this. Can y be 0? And when y is 0, x is these two things. Do you agree? When y is 0, x is those two things. So y can be 0. Could y be negative 5? When y is negative 5, is there an answer for x? Look, this goes forever in this direction. I didn't draw it, but this thing goes forever that way. If y was negative 5, which is right there, is there an x for that? Yes, right? There is. If y was negative 1,000,000, way down here, is there something that x is going to be over there? Yeah. Can y be 3? No, y is never 3. You see what I'm saying? There's nowhere that this never has a y as 3. Can y be 10? No, there's nothing. This thing goes. So then, what is the range then? The range is, what is all the things that y can be? According to this, y could be 1 less than or equal to 1. To answer this would be y would be less than or equal to 1. Does that make sense? Y can't be 3. It's not there. There's nothing there. Got it? Okay. Let's tell me. I'm going to give you this. I want you to tell me the domain and the range. Okay. I'm just going to give you this, and I want you to tell me the domain and the range. All I want is the domain and the range for that. Okay, so you're looking. I'm going to come up here. I want you to see this. This is just something that's so visual, and once you get it, this is the simplest part of the answer. X. Which way is x? Left and right. Right? X is this guy. Right? This arrow is starting here, and it's going that way. Is it going this way forever? Look at it. Is it going this way forever? No matter what I choose this way, will this arrow eventually get there? Right, no matter what I choose this way, this arrow, which is going that way, will eventually get there. It might be way up there, but it's going to get there, right? No matter where I choose. What about this way? Will the arrow eventually get there? Yeah. So then, the domain, all real numbers. No matter what I choose, eventually, it's going to get there. The range. Does anything down here work? No. It's all here and goes up. Now, what about 1,000,000? If y was 1,000,000, does the x ever get there? Yeah, right? It's going up forever. Not going down forever, going up forever. What is the domain then? So what is the range then? The range would be, what number is that? 3. Is it or equal to? Is 3 a part of it? Yeah, 3 is a part of it. So you'd say the range is y is greater than or equal to 3. Anything less than 3 is no good. It doesn't ever get there. Does that make sense? How have you got that? Does that make sense? You with me? Okay. There is no homework for today. We're going to do a different type of, this is called a special function. It's an absolute value function. You do need to know this. Eventually, in the end class, when I'm going to make you recall all of the parent functions that we've learned, because there will be many parent functions. And parent functions are cool because that just lets you know what is the normal, what is the most simple one, and then you just adjust to the parent function, right? So what is the absolute value parent function? How would you say it exactly? F of x equals the absolute value of x, right? That's the parent function for an absolute value. What's the parent function for slope-intercept form of a line? Y equals x. It's real simple. Y equals x. That's it. Or, I'm sorry, if I was going to say function, it would be f of x equals x. Right? Okay. You guys can go.